Hello everyone, welcome to MEP Work channel. In this video I am going to show you how to calculate duct friction loss or fan static head or the external static pressure for air fans. The external static pressure is very important in HVAC equipment selection. Air fans are an essential part in all HVAC equipment like air handling unit, fan coil unit, exhaust fans and fresh air fans. We will use this Excel sheet to calculate fan static head or duct friction loss. You can download it from the download link in the video description. And to calculate duct friction loss, we brought this ductwork example to practice on it. This duct network consists of fan coil units and air handling units. I chose this fan coil unit to find its external static pressure. FCU05. The first step for calculating duct friction loss is to determine the critical path of the duct. You can always determine it by experience, but if you are confused about two paths, you should calculate the two paths and take the higher static pressure. In our example, this will be the critical path. We take the supply duct and the return duct in consideration. Why this is the critical path? It is the longest one and it has many accessories and fittings. These are fittings: reducer, takeoff, reducer, 90-degree elbow, takeoff, reducer, volume damper, fire damper, transition, flexible duct, and sealing diffuser. Also, the return duct contains plenum, 90-degree elbow, volume damper, reducer, and wire mesh. Also, you will take this return sealing diffuser in consideration. Let's start. This is the calculation Excel sheet. In this part, these are the project data. You fill all the data in this part. The unit number in our case will be FCU05. Don't forget to change it also in this tab. This part is the general data. It contains duct material. In our example, it will be galvanized steel. Also, the roughness coefficient, the altitude coefficient, the air density, and it will be used in our calculation. In this part, we will calculate the duct pressure losses. We will fill all the red cells, the flow, liter per second, the length in meter, the duct size, width and height in millimeter. In this part we will calculate the duct fitting and pressure losses. These are the duct fittings. You will add the quantity of every fitting in this part. Every duct part contains its duct fittings. And in this part you will calculate the accessories pressure losses. You will add the quantities of accessories in this table. After that, you will get the results in this table. Let's apply these calculations on our example. This is the critical path, as we said before. And this duct starts with a fitting. So we will assume this is a duct. And this is the fitting. This is a flexible connection and its size will be about 850 and the depth of the duct will be about 200 millimeter and the flow will be 820 liters per second. And assume the length as 100 millimeter. And the size, the length, now we will add the fittings. It's a contraction, one contraction at this duct part. The duct pressure drop is calculated in this cell, and the fitting pressure drop is calculated in this cell. The total pressure drop is calculated in this cell. After that, we will go to the second part of the duct. Measure the length, 875, the flow 820 liters per second, the size is 450 times 400. This is the second part. Apply this calculation for this cell, also this one. Enter the duct fitting at this cell. In our case, they are 2 branches and 1 contraction. This volume control damper is not taken in consideration as it's not on the critical path. 2 branches and 1 contraction. To the third part, and duct fittings on this part will be a branch and a reducer. 1 branch and 1 contraction. To the fourth part, its length will be this part plus this part also. The flow will be 235 and the size 200 times 350. And the fitting, one elbow 90 degrees, and a branch and a reducer. to the fifth part. And the fitting on this part is a transition on this part. A transition between rectangular duct to round duct. The volume control damper and fire damper and the flexible connection will be added to the duct accessories. One transition on this part. The second step is to add the return duct to the duct pressure losses. We will start with this duct, 400 times 400, and the flow will be the total flow of this unit. The fittings on this part are a 90-degree elbow and a reducer. One elbow and one contraction. The final part is this bell mouth. Its size is 650 times 500. Assume the length 100. And the fittings on this part is a wire mesh. One wire mesh. The next step is to add all accessories on this critical path to this table. Accessories pressure losses. Let's make a quick survey. The accessories on this duct are a volume control damper, a fire damper, a flexible connection, a supply diffuser, and the planer box. Also, we will take one of these return diffuser in consideration. They are 1, 2, 3, 4, 5, but we only take one supply diffuser in consideration, so we will take this also in consideration. One supply and one return. Fire damper, one fire damper and one volume damper, one supply diffuser, one return diffuser, one planer box, one flexible duct, there is another volume damper in this part, so they will be 2 volume damper. These are all the calculations. The final results are summarized in this table. The duct pressure drop is found in this cell. The duct fitting pressure drop is found in this cell. And duct accessories pressure drop is in this cell. And the total pressure drop or the total static head is 132 Pascal or 0.53-inch water gauge. And this is the external static pressure for the fan. You can add a factor of safety, for example 10%. You can add this final result in this cell by multiplying it by 1.1, and this will be the total static pressure of the fan. And you should note that this is the external static pressure of the fan, and the total static pressure is the sum of external static pressure and the internal static pressure. The internal static pressure of the fan coil unit or the air handling unit is given by the supplier or the specialist. You can get it from the material submittal or the product catalog. We finished our video. Don't forget to subscribe to our channel and see you in the next video.